Welcome to our online video lecture. This particular video lecture covers the topic of elasticity of demand. Before we start talking about the specifics of elasticity, let's do a quick review of demand and the demand curve. So demand is a schedule of the various amounts of a good or service or a resource that buyers are willing and able to purchase for a series of prices for a specified amount of time, ceteris paribus. So other things being equal, the most important determinant of quantity demanded is the price in the market. If we look at this demand schedule on the left, either in the tabular form or graphically on the graph, we can see this inverse relationship between price and quantity demanded. And for that reason, there is a downward sloping demand curve. So demand is typically a downward sloping demand curve, which demonstrates that inverse relationship between price and quantity demanded. And a quick review of the law of demand. The inverse relationship between price and quantity demanded, meaning that if price goes up, quantity demanded goes down. If price decreases, quantity demanded increases. The reasons for this are: number one, basic common sense; number two, diminishing marginal utility; and number three, the income and substitution effect. Now, elasticity is a measure of how responsive are buyers to changes in price. In other words, if price goes down by a certain amount, do buyers tend to buy a bunch more or just a little bit more? And if price goes up a bunch, if price goes up some, do buyers tend to react quite responsive or not all that much? So elasticity is simply a measure of how responsive are buyers to changes in price. Price elasticity of demand, as I just said in the previous slide, is a measure of how responsive buyers are to changes in price. Remember, there is always an inverse relationship between price and quantity demanded. The question is, how responsive are buyers to that change in price? So we're going to talk about elasticity of demand, and we'll define demand as relatively elastic or inelastic. So you should get used to these terms and understand what they mean. If we say demand is relatively elastic, economists interpret that particular idea meaning buyers are relatively responsive to changes in price, as opposed to demand being relatively inelastic, meaning there is still some response to change in price, but not quite as responsive to change in price. So again, if demand is relatively elastic, buyers are highly responsive to change in price. If demand is relatively inelastic, there's some response, but not a great deal of response by buyers to changes in price. Now, how do we measure elasticity? Elasticity, defined down bottom, measured as percentage change in quantity demanded over percentage change in price. This will yield what economists refer to as the coefficient of elasticity, this formula, this mathematical formula. Notice, and this is very important, we are measuring percentage change in quantity demanded over percentage change in price. We're not measuring change in demand over change in price. It's percentage change in quantity demanded over percentage change in price. There are several determinants of elasticity, and these typically help us understand whether demand is going to be relatively elastic or relatively inelastic, meaning relatively responsive to changes in price or not all that responsive to change in price. The first determinant or characteristic of elasticity is substitutability. If we're examining the market for a particular good, the first question we have to ask: are there any substitutes for this particular good or service? If there are a great number of substitutes for a particular good or service, Demand tends to be relatively elastic because consumers have choices. So if we say, okay, if you think about a market, say for soft drinks, right? If you go to your typical convenience store and look on the shelves, there are literally 50 to 100 choices of different drinks available to consumers in the soft drink arena. So we say, how responsive are consumers to the change in price of Minute Maid orange juice? Well, obviously, Minute Maid orange juice is one option among the many, so there's many substitutes for that particular product. All right, so if we examine that market, we would say that demand for that Minute Maid soft drink is relatively elastic. Consumers are going to respond a great deal to a change in price. As opposed to something like gasoline, there's not a great number of substitutes for gasoline. So demand tends to be relatively inelastic in situations where there aren't very many substitutes. Proportion of income, the second characteristic or determinant of elasticity of demand. When we evaluate big ticket items, things that cost a great deal of money, demand tends to be relatively elastic, responsive to change in price. Something like an automobile, right? Expensive furniture. Demand for very large ticket items tends to be responsive. Elasticity of demand tends to be responsive, elastic for big ticket items, as opposed to goods or services that cost something like $1, $2, $5, $10. We tend not to even care that much about changes in prices. So for small ticket items, for goods and services that don't cost much, demand tends to be relatively inelastic. The typical example of this is a box of salt. When you ask most consumers how much does a box of salt cost, they don't know off the top of their head, and more importantly, they don't care because if the price of a box of salt doubles, they're typically going to buy the same amount of salt, right? And this also goes along with our first characteristic. Number one, there's not a lot of substitutes for salt, and number two, it's not a very high percentage of buyer's income. It doesn't cost that much. Our third characteristic, luxury versus necessity. This one should sound like common sense to you as well. When we examine the market for luxury goods, for jewelry, something you don't have to purchase, well, buyers tend to be rather responsive to changes in price in that particular market. So the elasticity of demand for luxury items tends to be relatively elastic as opposed to necessities. If you think about things that you need to buy, like toothpaste and shampoo, these type of consumer staples, demand is relatively inelastic, not all that responsive to price, to changes in price, because we have to buy them. The last determinant or characteristic of elasticity of demand is the time. In the short run, in the immediate market, demand tends to be relatively inelastic. Buyers are not all that responsive to changes in price. Think about the last time you attended a sporting event or a concert, any type of venue where you don't really have a choice when it comes to buying a bottle of water. In that particular instance, you're going to pay the exorbitant price of water because you don't have time. You only have the time you're at the event to consume that water. And you want it at that time. Right? Another good example of this is something like, all right, what about automobiles and the price of gasoline? Right now, in the year 2013, in October, gasoline is selling for roughly $3.35 per gallon. If gas prices were to go to $6 per gallon, and you've already purchased a very large automobile, a pickup truck, or some other type of large automobile, for the time being, you really have no choice. You can cut back on some of your superfluous driving, some unnecessary driving, but for the most part, you still have to drive to work, and you still have to drive to school, or you still have to drive to wherever the necessary places are in your life. You can cut back on some type of driving. But the next time you purchase a car, 5 years from now, more time, you're going to buy a more fuel-efficient automobile. So given a longer period of time, demand tends to be more elastic, relatively elastic, responsive to change in price. Now that we have some of the basics down about elasticity, let's go over some of more of the particulars. First, why do economists use percentages? In other words, the coefficient of elasticity measures percentage change in quantity demanded over percentage change in price. Why don't we just go ahead and measure change in quantity demanded over change in price? There's two reasons why we use percentages. The first one is should be relatively straightforward and common sense, is that if you look at something that's priced rather large, so an automobile, if an automobile is priced at $30,000, a $1 increase in price doesn't really change consumers' choice about purchasing that particular item. So if you're going to buy a car this week and you plan on the car price being $30,000 equal, I mean exactly, and you got to the car dealership and all of a sudden the man or woman selling the car said, well, I have bad news, the car is now selling for $30,001. It's not going to deter many people from purchasing this product. So it's a very small change in price, as opposed to something that cost $1, which goes up by $1 in price. Obviously, that's a 100% increase. So the first reason why we use percentages and not actual numbers is that for large ticket items, a couple dollars is virtually meaningless. But for something that you traditionally spend somewhere in the neighborhood of $2 or $3, a couple dollar difference is huge. The other reason why we use percentages is because it allows this economists to speak in general terms about markets. So for instance, we would say something like the market for consumer staples tends to be relatively inelastic. In other words, how do buyers respond to change in price of something like toothpaste? Well, we know that toothpaste is a necessity and there's not very many substitutes for toothpaste, so demand for such an item tends to be relatively inelastic. It's good to make a point at this particular juncture of studying elasticity. Remember, always be specific on which market you are analyzing. The market for toothpaste, demand for that particular good, tends to be relatively inelastic, not all that responsive to change in price. Be careful. If you were examining the market for one brand of toothpaste, this would be a different story. So in general, there's very few substitutes for toothpaste, but there are many substitutes for, say, Crest toothpaste. So the demand for one particular brand in a market tends to be more elastic. Another important idea here is we eliminate the minus sign. If you think about demand, it's a schedule of the various amounts of a good or service or a resource that buyers are willing and able to purchase, series of prices for a specified amount of time, ceteris paribus, other things being equal, price the most important determinant. We know that there's an inverse relationship between price and quantity demanded. If price goes up, quantity demanded goes down. If price goes down, quantity demanded goes up. So when we look at our elasticity coefficient formula, one of the two, either the percentage change in price or the percentage change in quantity demanded, is going to have a negative sign, because if we have a percentage decrease in price, typically there's going to be an increase in quantity demanded. In that case, our denominator would have a negative number. Obviously, if price goes up, percentage change in quantity demanded, the numerator is going to have a negative in front of that particular number. So for ease of use, we just take the absolute value when we interpret the coefficient of elasticity. So let's look at some interpretations of elasticity. So when we measure percentage change in quantity demanded, the numerator, over percentage change in price, the denominator, if it yields a result of anything greater than 1, we tend to call that elastic. We would say demand is relatively elastic for that particular item. So the greater the number, so a coefficient of elasticity of, say, 1.5 is not quite as elastic as 2. And obviously 5 would be even more elastic. So the larger the number above 1, the greater the elasticity, the more responsive consumers are to change in prices, or buyers are to change in prices. The opposite would be true if we measure percentage change in quantity demanded over percentage change in price, and it yields a result of something less than 1. We interpret that result as relatively inelastic. There is some response by consumers to the change in price, but not a very large response. Remember, the law of demand always exists. In other words, If price goes down, quantity demanded will go up, and vice versa. If price goes up, quantity demanded will go down. But if we measure percentage change in quantity demanded over percentage change in price, and it yields a result of something less than 1, demand is relatively inelastic, not all that response to change in price. There is the rare outcome where we measure percentage change in quantity demanded, and it has met with the exact same, or we measure percentage change in price, and it matches up the exact same percentage change in quantity demanded, where it yields a result of exactly 1. Economists refer to this as unit elasticity. So now that we know some of the basics of elasticity of demand, we're going to investigate this price elasticity of demand formula in a little more detail. We know that in its simplest terms, elasticity measures percentage change in quantity demanded over percentage change in price. We also said that we ignore the minus sign, and we know how to interpret the coefficient of elasticity. Any result greater than 1, we say demand is relatively elastic, that is responsive to change in price. And any result or coefficient of elasticity of something less than 1, we interpret that as demand is relatively inelastic, not all that responsive to change in price. But economists quickly noticed, and you would notice as well if you're a math type person, is that there is a problem when we look at elasticity over a range of price. In other words, if we were to go from $4 to $5 in price as opposed to moving down from $5 to $4, there would be different percentage changes. So an increase in price from $4 to $5 is a 25% increase in price, and a decrease in price from $5 to $4 is only a 20% decrease in price. Same thing with quantities over that range. If quantity demanded had, say, increased from 1 to 2 when price fell from 5 to 4, that would be a 100% increase in quantity demanded. And if quantity demanded fell from 2 to 1 when price increased, it would be a 50% drop in quantity demanded. So economists came up with this midpoint formula of using averages. Now here is the midpoint formula in its longest sense, right? You take the change in quantity over the sum of the two quantities divided by 2, all over top of the change in price over top of the sum of prices divided by 2. Now that's a very lengthy and wordy formula. It's also something where students tend to get lost in the math and tend to forget about the importance of the economics, but on one of the next slides we're going to have some of these coefficients of elasticities already determined for us, but it's important for you to know that the textbook authors actually employed this formula, the midpoint formula, to calculate the coefficient of elasticity over those price ranges. So it's not as if I'm going to make you responsible to plug in numbers. That's really just sort of like 7th grade math, making you plug in numbers. But it is important for you to understand where the formula came from, what the formula represents, and most importantly, how to interpret the result of the formula as far as our coefficient of elasticity. Sometimes when teaching elasticity, it is beneficial to go over the extreme cases and then to bridge our way into the more typical cases. So what do we have graphed up top here? This is a graph that represents perfectly inelastic. So if you notice, this demand curve is perfectly vertical, right? So if you can imagine, if you look at the quantity axis on the horizontal axis, let's assume that this demand curve is perfectly vertical at 50 as far as the quantity. If you compare this with price, you notice that it doesn't matter to this consumer what the price is for this particular item, right? They're going to demand exactly 50 no matter what price you charge them. So if the price of this particular good or service or item was, say, 50 cents, they would want 50 units. If it was $1, they'd want 50 units. If it was $50, they'd want 50 units. So perfectly inelastic means that there's absolutely positively no response to change in price by the buyers in the market, by the consumers. Now this is an extremely rare case, but the best example of this is when there's some type of absolute medical necessity for such an item. So if you think about diabetics and insulin, it's not as if they have a choice. They have to purchase the amount which is prescribed for their well-being. Now, having said that, of course, if they're not going to take any more or any less than they need, so if the price was $1 per milligram, they would still purchase 50 milligrams. If it was $50 per milligram, they'd still purchase 50 milligrams. So again, the important thing to remember here is when demand is perfectly inelastic, there's absolutely positively no response from consumers to change in price. And this is an extremely rare case. What about the other extreme? What about perfectly elastic? Notice here that buyers are completely responsive to change in price. In other words, if price goes up just the slightest bit, right, buyers will respond by not buying any at all. Right? Likewise, if the price goes down, interestingly enough, quantity demand won't change. Here's the reason, because this is an example of one seller in a purely competitive market. This will have extremely important implications when we study pure competition. If you are one rice farmer among the many rice farmers in a country producing rice, and you're producing a standardized product, you have absolutely positively no control over price. So if you look at this graph for perfectly elastic and assume that price is $4 in the market, so demand is perfectly elastic at $4. This rice farmer can sell as much rice or as little rice at the $4 price as they wish, but they have absolutely no control over price. If the farmer raises price just the slightest bit, to say $4.10, no one will buy rice from this farmer. Likewise, they'd be shooting themselves in the foot by lowering price, because they can get the market price. They can sell at the market price. So the perfectly elastic demand curve has some good further application when we study pure competition as one of our market models in the next couple of chapters. So as we've seen prior to this slide, one way economists determine elasticity or responsiveness to change in price is by using the percentage change in quantity demanded over percentage change in price formula to determine the coefficient of elasticity. Another method of determining elasticity, and this one is actually extremely important, it has a lot of real life application, is what's called the total revenue test. So first, how do we calculate total revenue? This is actually a pretty simple idea. If we think of any item that a producer is selling, a firm is selling, you take the price at which they're selling it times the quantity sold, and that will give you a firm's total revenue. So for instance, if they're selling light bulbs and they're selling the light bulbs for $2 a piece and they sold 100 of them, well, obviously price is 2, quantity is 100, 2 times 100, total revenue would be 200, say, for that day or for that week. So how can we use this idea of total revenue and connect it with elasticity of demand? Well, first, what if demand is elastic? What we're going to find out here is that when demand is elastic, price and total revenue move in the opposite direction of one another. So let's look at the graph that's on this particular slide of this demand curve, and you can see it's relatively elastic demand. It doesn't have a lot of steepness to the curve. Matter of fact, this one's rather flat. That's one of the characteristics of an elastic demand curve. So if demand is elastic, it's going to graph in this nature to begin with. But let's talk about the total revenue test. Currently, this firm is charging $2 per unit, and they're selling 10 units per week. All right, so you can see $2 on the vertical axis, 10 units on the quantity axis. So 2 times 10, they're 2 times 10, and means that their total revenue is 20. So remember, if demand is elastic, responsive to change in price, right, price and total revenue will move in the opposite direction. In other words, if price goes down, total revenue will increase. So that's exactly what happens here. This firm lowers the price from $2 to $1, but look what happens to total revenue. Total revenue increases from 20 to 40. They're now selling 40 units at $1 as opposed to selling 10 units at $2. You can see this geographic region of this rectangle more than makes up for the for the higher price they were charging previously. Now, of course, this would work in both directions. If demand is relatively elastic, you would know that increasing price from $1 to $2 would cause total revenue for this firm to decrease from $40 to $20 per week. Now let's use the total revenue test to evaluate when demand is relatively inelastic, that is not all that responsive to change in price. So this particular demand curve on this slide graphs that exact scenario where demand is relatively inelastic, not all that responsive to change in price. You can see that this demand curve is relatively steep as opposed to the previous slide. So employing the total revenue test, if demand is inelastic, price and total revenue will move in the same direction. In other words, if a firm lowers price, total revenue will actually fall, and if a firm increases price, total revenue will actually increase. So if we look at this current situation, right, the firm is charging $4 per unit and selling 10 units per week, so total revenue is 4 times 10 or 40. Will they sell more if they decrease price? Yes, they will. We can see that if price falls from $4 to $2, from $4 to $1, quantity demanded will increase from 10 to 20. So yes, there is that inverse relationship between price and quantity demanded. But because demand is inelastic, the total revenue test tells us that decreasing price actually causes total revenue to fall, because price and total revenue will move in the same direction. This firm lowers price from $4 per unit to $1 per unit, and total revenue falls from $40 per week to $20 per week. Remember, there is that rare case when we experience what's called unit elastic. Remember, unit elastic means the coefficient of elasticity will be exactly 1. So in this case, if price increases by a certain amount, total revenue will not change, or if price decreases by a certain amount, total revenue will not change. Let's look at this case graphically. Notice the shape of the demand curve to begin with. It has some curvature to it. So if this firm is charging $3 per unit, they sell 10 units per week for a total revenue of $30, as opposed to charging $1 per unit and selling 30 units per week. All right, so the decrease in price from $3 to $1 increased quantity demanded from 10 to 30, and notice total revenue has not changed. Total revenue remains 30. So this firm can either charge $3 per unit and sell 10 units per week, or charge $1 per unit and sell 30 units per week. If you take an advanced economics course, this will be referred to as indifference. In other words, the firm is indifferent to these two outcomes because they yield relatively the same exact result. Obviously, there's much more to this in the real world, and higher level economics classes would evaluate this. But for our sake and purposes here, just understand the idea of if demand is unit elastic, total revenue does not change with the change in price. Now let's reinforce some of the principles about elasticity of demand we have been studying thus far on this video with some actual numbers. So this is from the textbook. It is an example of a theoretical movie theater run by, say, a campus. And we start off with some simple ideas. First, on the far left column, we have total quantity of movie tickets demanded per week. Now this is in thousands. Next, we simply add the price per ticket. So this is our demand curve, right? Same idea of the schedule of the various amounts of in this case, a service that buyers are willing and able to purchase for a specified amount of time. Right? And this is per week. Right? So ceteris paribus, other things being equal, price is the most important determinant of quantity demanded. So if this firm charges a high price, say $8 per ticket, they can expect only 1,000 people to visit the movie theater that week. If they charge a much lower price, say $2 per ticket, obviously 7,000 people would visit the movie theater. Here we have our coefficient of elasticity over these price ranges. Now remember, earlier in the lecture, we talked about the idea of the midpoint formula. So we know that elasticity measures percentage change in quantity demanded over percentage change in price. And then we talked about how over a range of prices, say between $8 and $7, if we move from 8 to 7 or 7 to 8, we'd come up with different percentages. Likewise, if we went from 1 ticket to 2 tickets as opposed to going from 2 tickets down to 1 ticket, we'd have different percentages. So know that these coefficients of elasticity in column 3 were calculated using that midpoint formula. Again, I'm not so worried about you plugging numbers into a formula as I am you interpreting the results of that formula. So here we have coefficients of elasticity over the various price ranges on our demand curve. And notice a pattern, right? Demand is relatively elastic at the high price ranges. So between $8 and $7, $7 and $6, and $6 and $5, right? And then as we move down the price range, right, we have one little spot in that price range between $4 and $5 where demand is unit elastic. And then below that, demand turns relatively inelastic. We're going to see this graphically on the next slide, but this is typical of your of any downward sloping demand curve. So of your typical downward sloping demand curve, we can expect to have both an elastic region and an inelastic region. Now remember, this is going to be important because the firm is trying to maximize total revenue, which we graph on the next column. So this is pretty easy for us to calculate these total revenue numbers, right? So if the firm charges, in this case the movie theater charges $8 per ticket, they'll sell 1,000 tickets, so total revenue would be 1,000. And if they charge $7, they'd sell 2,000 tickets, total revenue would be 14,000, right? So you can see where we're getting those numbers. So obviously, this firm wants to maximize total revenue. So they really have a choice of either charging $4 per ticket and having 5,000 customers per week, or charging $5 per ticket and having 4,000 customers per week. Either one of those two price choices will yield a total revenue of 20,000. Notice that demand is unit elastic between the $4 and $5 price range. Again, before we see this graphically, it's important to emphasize that your typical downward sloping demand curve has both an elastic region and an inelastic region. So what we're going to do on the next slide is we're going to graph the data here. All right, so we're going to graph the demand curve. Then we'll make some generalizations about demand curves. We're also going to graph the total revenue curve, which we haven't done yet. So here we're going to graph on the same slide both the demand curve and the total revenue curve. Obviously, the demand curve is graphed up top, and the total revenue curve, using the data from the previous slide, is graphed down bottom. All right, you can see that the total revenue curve graphs as a parabola. You may remember studying the parabola in high school. The top of the parabola is called the apex, right? So it's easy to come up with these numbers and to graph these if you were ever asked to do so, but let's interpret the graph. Remember, we talked about the idea that a typical downward sloping demand curve has both an elastic and an inelastic region. So this upper left-hand northwest version, this upper left-hand northwest area of the demand curve tends to be relatively elastic. So if you notice, that part is highlighted in the orangish, tannish color, and it says that elastic, so a coefficient of elasticity is something greater than 1. Now that's a mathematical principle. It just should make sense to you, because what's happening over that region is that you have relatively small percentage changes in price, your denominator, met with relatively large percentage changes in quantity demanded. So it's over the $8 to $7 range, right? Quantity demanded increases, from 0 to 1 or from 1 to 2. So a 100% increase or a 50% decrease on top of a relatively small percentage change in price is going to yield something greater than 1, right? Then we have that middle part of the demand curve where we say demand is unit elastic, and for us that was that $4 to $5 price range. So a change in price does not actually impact total revenue whatsoever. And then finally we have the relatively inelastic, right, this southeast region of the demand curve, the lower right-hand portion of the demand curve, right, where demand is relatively inelastic, where consumers are not all that responsive to change in price. And again, mathematically, the opposite is occurring here, right? Where we have relatively large changes in price, our denominator, with not very large changes in quantity demanded, so our numerator. Right? Now, a couple things about this we should take away before moving on to the next slide. If demand for our product is relatively elastic, it makes sense for this firm to lower price. So in other words, if this movie theater, movie house was charging $6 per ticket, right, they'd be selling 3,000 tickets per week. Right? 6 times 3 is $18,000. So the firm could actually increase total revenue by decreasing price. Right? In other words, dropping price from $6 to $5 increases total revenue from $18,000 to $20,000. Likewise, this is one of the big misnomers with the general public. In other words, people think that firms can always raise price and collect more revenue. But if this firm is operating in the elastic portion of the demand curve, increasing price from $5 to $6, yes, they will receive more per ticket that they sell, but because demand is elastic, that is to say responsive to change in price, right, it would actually hurt the firm, because when demand is elastic, price and total revenue move in the opposite direction. So increasing price actually decreases total revenue. Right? Now, of course, the opposite is true if we look at the inelastic portion of the demand curve. If demand is relatively inelastic, right, this firm is made better off by increasing price. So an increase in price from $1 to $2 increases total revenue from $8,000 to $14,000. Likewise, the firm can continue to increase price for a while, increasing price from $2 to $3. An increase in price, if demand is inelastic, increases total revenue, in this case from $14,000 to $18,000. Right, so it's very important that you understand the idea of the total revenue test, that if demand is elastic, price and total revenue will move in the opposite directions of one another. And if demand is inelastic, price and total revenue will move in the same direction. It's also important you understand that in the real world, firms should make some type of determination as to elasticity of demand for their product or service. A firm would never want to raise price for their product or their service if demand is elastic, responsive to change in price. Likewise, a firm would definitely want to raise price if demand for their product or service is inelastic. So we will finish up our video lecture, our study of elasticity of demand, by talking about some real-world examples or some applications of elasticity of demand. The first one is we look at large crop yields. Now remember our characteristics of elasticity: number of substitutes, percentage of income, luxury versus necessity, and a time factor. So when you think about the typical person's demand for agricultural products like corn and wheat and rice and potatoes and such, well, there's not very many substitutes for agricultural products. Likewise, they're not a high percentage of our income, and they are mostly a necessity, not a luxury. So for that reason, demand tends to be relatively inelastic. So remember, if demand is inelastic, price and total revenue move in the same direction. So when we talk about a bumper crop, when farmers have a year where there's spectacular growth of their agricultural products, whatever it is they're growing, the wheat or corn or rice, that tends to increase supply a great deal, right, which pushes down price. But remember, because price and total revenue move in the same direction, price goes down, so does total revenue. Because when price of agricultural output goes down some, we don't respond by buying a ton more. Sure, we'll buy some more, but demand is relatively inelastic. It's not all that responsive to change in price. So bumper crops tend to hurt farmers. What about excise taxes? And why is it that governments tax things like alcoholic beverages and cigarettes? Well, this is the same idea as the large crops, but in reverse. In this case, people are typically addicted to these type of goods, right? Typically, smokers are not all that responsive to changes in price. So if you ask a group of 40 people how many of them smoke, and if say 30 of them raise their hand and say they smoke, you ask the other 10, if cigarettes were free, would you smoke? 95% of the time they would say no. And if you ask the 30 people who smoke, what would happen if they doubled the price of cigarettes? 28 of the 30 would say they would still purchase or buy cigarettes. Now, of course, governments understand this. There is some response to the increase in price, but because price and total revenue move in the same direction, an increase in the price, increased tax, that means more revenue collected by the governments. How about the decriminalization of illegal drugs? This is an argument we looked at in class in some detail, right? Well, what if demand for, say, marijuana and cocaine is relatively inelastic, not all that responsive to change in price? We know that if we decriminalized these particular drugs, there would be much more of the supply on the market, which would drop price dramatically. So price would go way down, but quantity demand, it wouldn't increase all that much. There would be some response, but not a great response. The last one's an interesting argument here about a real-life application is the minimum wage. We'll look at this in more detail in the next slide. Economists often debate whether a minimum wage is actually good or bad for employment and employees. Right? If it actually will hurt the number of people working. Right? So let's look at that particular application in more detail on the next slide. Let's discuss in more detail the idea of how elasticity of demand can help us understand the argument about minimum wages and the minimum wage increase. Let's look at these two graphs. The graph on the left is a relatively elastic demand curve responsive to change in price. The graph on the right is a relatively inelastic demand curve. Now here's the only thing, pay attention for this part. Assume P2 is the first price in the market. In other words, that's the price before the minimum wage increase. Okay, so P2 was our original price. So let's assume for the time being that demand is relatively elastic. That is to say, the buyers of labor, in this case the firms, the employers, right? Your Burger Kings and Dunkin' Donuts and maybe even Walmarts and McDonald's of the world, because you talk about people typically earning at the minimum wage. All right, let's say the demand is relatively elastic, that is to say responsive to change in price. So if the government mandates an increase in price of labor, because this is the labor market where labor is the resource and the buyers are, in this case, the businesses, price increases from P2 to P1. Notice that if demand is relatively elastic, notice the huge response in quantity from Q2 down to Q1, which means that because the government has forced producers, firms, businesses to pay a higher wage in the marketplace, many people lost their job, right? So if you look at the number of people employed at Q2, at the original price P2, when the government forces these employers to pay a higher wage, if demand is relatively elastic, right, the minimum wage law might actually make a lot of people worse off because they're going to get put out of work, right? The firms respond by saying, yes, we know we have to pay a higher price, but guess what? We're going to employ fewer people, right? So if you are against minimum wage laws, if you think minimum wage laws are a bad idea, you believe that the graph would simulate something or look like something on the left-hand side where demand is relatively elastic, as opposed to the graph on the right-hand side where we have the inelastic demand curve. Right? Again, start with P2, the original price in the market, at Q2. Right? So the government mandates that minimum wage increase. Say, they say the minimum wage was $7 per hour, and now they're forcing it all the way up to $9 per hour. Well, if you believe that demand is relatively inelastic, not all that responsive to change in price, that these employers need these workers anyway, right? Then you would be a proponent of minimum wage laws. Now, everyone agrees that there will be some response in the marketplace to an increase in the wage, right? An increase in the price here. If price increases from P2 up to P1, quantity demanded, even if demand is inelastic, will fall from Q2 to Q1. But notice, a relatively significant increase in price from P2 to P1 causes only a small number of people to be put out of work because of the minimum wage laws. All right, so this is one of the really good applications of elasticity of demand and a real-world application. There's many articles you can actually read about this debate among economists today.